here's the review for the Geometry AB Parallel and Perpendicular Lines test. I'm on packet page 32 right now, if you could go to that real quickly. The test will consist of 16 questions for 50 points. It'll be a mixture of some multiple choice, some short answer where you have to show some algebra and do some justification, explain. On page 32 is all the theorems we have gone over as far as if you are given parallel lines, all the special types of angles you could form. And then also if you want to prove parallel lines, all the different ways to do that. This is what I'm expecting. If you answer an algebra question and it asks for a justification or a theorem, here is what I'm looking for. Okay, going to the next page. Please remember your index, the theorems you wrote down on your index cards on Tuesday in class. There will be one of the two proofs that I'll be giving you will be involving those theorems. We'll do a practice one in a second using one of your index card theorems. You are not allowed to have your index card theorems with you during the test next week, but again, use them as a study guide. Next is all the different forms of line, all the different equations that we talked about on Wednesday in class, your standard form, slope-intercept form, and point-slope form. Please be ready to write equations of parallel and perpendicular lines. I've added that in down here that you know the slopes of parallel and perpendicular lines. A quick review, the slopes of parallel lines are the same slopes, and the slopes of perpendicular lines are negative reciprocals, which we went over Wednesday in class. So please be prepared to write an equation of a line that's parallel or perpendicular to a given line. Constructions we did on Thursday, be prepared to construct parallel lines and perpendicular lines. I am telling you right now, not hiding anything, that both will be on there. I am going to ask you to construct a parallel line and a perpendicular line. I don't know how many I put on the review in the following pages, but you don't need review to do the constructions. You can go back, you can look at the video, all right, from Thursday, or just take out a sheet of paper, draw a line with a straight edge, put a point somewhere on your paper and say, okay, can I draw a parallel line through this point? And then say to yourself, can I draw a perpendicular line through this point using my compass and straight edge only? So that easy way to practice. You don't need review problems for that. And then finally, there will be two proofs on the test, 5 points each. I am telling you what the proofs are. Well, the first proof is I am going to give you parallel lines and ask you to prove a pair of angles congruent. And the second proof is going to somehow use your index card theorem. So look back on Tuesday night's homework, Tuesday's classwork, to make sure you're good to go there. What I want to do with you before I let you go on your own is 2 review proofs. So if you could keep going and find proof number 1 for me. You can pause the video right now and set up your statements and reasons. I'm just going to go ahead and go forward. So if you need time, pause the video right now so you can set up your statements, reasons, and mark your diagram. Okay, first part. This is a 2-part proof. The first part, we are asked to prove that BF is parallel to CE. BF parallel to CE. Well, we were given perpendicular lines, and we know perpendicular lines form right angles. So I look at BF and AD where they meet. So I have a right angle here and here. It also tells me CE is perpendicular to AD. So I do have a right angle here and here. Now, how am I going to get parallel lines from that? I'm not even going to use the right angles. I'm going to use one of my index card theorems I had on Tuesday in class. And that says the following. If you take a look at BF, it's perpendicular to AD. And so CE. CE is perpendicular to AD. And I know from my theorems that if I have 2 lines, BF and CE, that are perpendicular to the same line, in our case AD, those 2 lines have to be parallel to each other. So the theorem, 2 lines perpendicular to the same line are parallel to each other. Okay, so that takes care of part number 1 right there, that those 2 lines now are parallel to each other. Okay, moving on. There's a second. I continue my proof. I don't set up a new statements and reasons. Show that PFB, so let me highlight that angle so I know which one it looks like. PFB and QCE are congruent to each other. Now take a look at those two angles here, guys. Notice PFB. BF is part of that angle. Look at QCE. CE is part of that angle. We know BF and CE are parallel to each other. And take a look. The other half of those angles are QC and PF, a common transversal that they both share. So that tells me right away that those two angles are special types of angles. I just have to figure out what they are. All right, so I take a look. These two angles are outside, clearly outside my parallel lines. And if this is my transversal, PCQ, they are on opposite sides of the transversal. So that makes these angles alternate exterior angles. And I know that they are congruent if I have parallel lines. So I don't need to put any more work into this other than this third step. Again, because I have parallel lines from step 2, that implies that my alternate exterior angles are congruent. Okay, so nice 3-step proof. Is there a way, going back to the parallel lines, BF parallel to CE, that you can do it? Yes, you could say that these are right angles. These two right here, take a look, these two right here are right angles. Perpendicular lines form right angles. You could then say they're congruent. Right angles are congruent, and then say, oh, now the lines are parallel because these are congruent corresponding angles. So there's another way to do it, but I figure most of you guys want to get right to it and get it done in 2 to 3 steps. All right, go to proof number 3 right now. Again, pause the video if you need to get it set up, or if you just want to, hey, if you want to just try to do it out on your own and then restart the video and see how I did it to see if it matches, might be a good idea as well. So you decide what you want to do here now. Okay, I am told that CE, ray CE, and segment AB are parallel to each other. And I'm also told that ray CE is bisecting angle DCB. So make sure you locate DCB because that angle is being cut in half. Now I see the word bisects and I may start thinking halves of equal quantities. But as we know from unit 2, 2 angles need to be cut in half, not just the one angle. I would need another angle to be cut in half to do halves of equal quantities. So that theorem is out of the question, but I can still use the fact that CE bisects DCB to say the following. Take a look. Angle DCE congruent to ECB by definition of a bisector. Yes, a bisector cuts an angle in half, but it also cuts it into 2 congruent angles. Okay, so DCB is being cut into 2 congruent angles. That will help us out in a second. So I've used the fact that CE is a bisector. I also have these parallel lines up here, CE and AB. See if you can find CE, AB. Can you find any special types of angles that have CE and AB as sides and one common transversal? The first pair I see are angle ECB and angle B, or I'll call it CBA. Those, if you take a look, those are alternate interior angles. And I know if I have parallel lines, which I was given, I know that alternate interior angles are congruent. There's one more pair up there, and this is a little bit tougher to see. All right, take a look at angle DCE and angle CAB. Take a look at those angles right now. Those angles are both on the parallel lines cut by the same transversal ACD. Those are corresponding angles. And if I have parallel lines, I know my corresponding angles are congruent. So we found 3 different pairs of congruent angles, 2 by parallel lines, 1 by a bisector. Now I got to fit it all together to try to get A congruent to B, which again is the same as saying angle CAB congruent to angle CBA. All right, here comes the dreaded substitution. Take a look at these 3 right here. I'm going to challenge you. Can you pick just 2 of them? Just pick 2 out of the 3 and get CAB congruent to CBA. So out of these three, can you choose just two and using substitution get CAB congruent to CBA? And I'm going to tell you, you cannot. It is impossible just to pick two only and get these two angles congruent, which means I'm going to have to do more than one substitution. So let's take these first two right here in statements 2 and 3. DCE equal to ECB, ECB equal to CBA tells me that by substitution, DCE needs to be congruent to CBA substitution. Okay, that involves statements 2 and 3 to get statement 5 by substitution. Now let's involve statement 4. I have DCE equal to CAB, and I just wrote down that DCE and CBA are congruent. So again, substitution will tell me angle CAB will be congruent to angle CBA. And that is a second substitution. This cannot be done using just one substitution. Okay. So that takes care of 2 review proofs right there. The remaining questions are in the remaining pages of your packet. You'll also notice I gave you some textbook pages and questions to try out that I think will be very helpful to prepare for the test next week. Every single answer is on the following pages of the packet. I wrote out every single proof and I did every single problem I suggested in the textbook for you. You will not see those answers on Aspen. They are in your packet at the end of the packet. All right, so now you can go ahead, you can work with other people, make sure you're working on the review, please. Email me any questions that you have, and we'll be taking this test next week, so go ahead and start reviewing now.